Okay, today's we like to cover the subject on hydrogen distribution system as a continuation of hydrogen production. In hydrogen production, we mainly cover green hydrogen using the electrolyzer, and we also briefly review the other method with the different colors representing different method of hydrogen productions. Now, once hydrogen gas is produced, so what do we need to do? Well, we need to distribute the hydrogen gas mainly through a pipeline system. We can also use the trucks and ships using the storage big tank, and in a way of compression and liquefactions. And the safety and infrastructure is a very important topics. And we can also use the pipeline blending rather than pipeline which is just for the hydrogen. Blending can be combine the CNG and hydrogen gas together to save a cost. The installation of the pipeline only for the hydrogen gas is very costly. So anyhow, today we will mainly cover the hydrogen pipeline for the hydrogen gas. Okay, chapter 4. If you have any problems in the lecture, this class, please send me your note to Kato or through this chat. Okay, well, this class lecture note collect all the proper subject we like to cover. And the chapter 4, is the hydrogen distribution system. Let me read the abstract of this chapter 4. This chapter explores hydrogen distribution via pipeline and trucks and ships and blending, addressing compression, liquefaction, and safety. Pipelines actually move 1,000 through 4,000 kilo per hour at cost of $0.1 and $0.3 per kilo in German, while trucks and ships enable flexible transport at a cost of $0.5 through $3 per kilo, while compression actually the pressure needs to be between ranging from 350 to 700 bar, and liquefactions, the temperature needs to be minus 253, which is the temperature liquefied, and certainly increase the density, but consume 5 to 40% of our energy. Well, as you can see that energy, the hydrogen transportations and distribution is much related to the cost, which can be the most cost effective. Not at this point, but considering long run. So the always when we discuss about this hydrogen distribution, we should focus on the cost. Well, some safety protocols and the blending and the scaling to 23,000 kilo pipeline and 40,000 station by 2050 needs the 200 to $300 billion, which is a lot. So as we are approaching to hydrogen society, this hydrogen distribution pipeline is another new field of the industry. So there can be a big business. Okay, so this chapter highlights distribution as a bottleneck, recurring innovation and investments. So we got some important issue summary, and one of the summary in here I can see that embrittlement, H2 gas, due to its characteristics, the molecule of hydrogen is so small and it can penetrate into any material, even especially the metal. So as you can see, hydrogen H2 can weaken steel. It's called embrittlement. So that's why we need a coating or high strength alloy, which is very expensive, raising cost to $1 to $2 million per kilo for new lines. So anyhow, that is the one we need to know. And the embrittleness, we need to have a very special coating inside the pipeline, the pipe, to prevent the penetration into a pipeline. So we could not use the conventional metal type pipeline. We have to have our own types of pipeline designated for the hydrogen gas distributions. That makes this pipeline very costly, very difficult. But anyhow, if there is a need, we as an engineer can develop technology and product. So anyhow, let's take a look at well, this is a very common slide we are using during this class. Once again, the hydrogen gas are produced through many different ways, and also hydrogen gas needs to be distributed. This is the one we like to cover. There could be several different ways of distributed hydrogen. We can convert to ammonia, NH3, especially for the shipping. And once we arrive in a port, then we can convert this ammonia back to hydrogen. And so many different ways of distributions, and this represent the pipeline. This all the yellow line represent the pipeline, and this pipeline, if they are inside the onshore, onshore means the under the ground, okay. And this pipeline can be through offshore seabed. Through sea. Then it's called offshore. The design methodology is different, but of course the purpose is the same. How can we safely distribute hydrogen, either gas or either liquid type, through this pipeline? So like to emphasize that offshore pipeline, hydrogen pipeline are being explored as a way to transport or distribute hydrogen, either pure form or blended. Pure form means the hydrogen gas itself, or blended with the natural gas. And from offshore wind farm or hydrogen production facility to, this is important. Offshore wind farm, what does it mean? Means that once we generate here, generate the electricity from wind turbine blade. This wind turbine blade can be either onshore or offshore. Well, if mostly these days the wind turbine blade installed in the offshore to increase the power. So offshore wind farm, once we generate the electricity, we can produce the hydrogen gas on that spot, and then we can transfer, distribute that hydrogen gas through a pipeline. Then we need an offshore pipeline. So anyhow, production facilities to shore, offering a potentially cost-effective and efficient alternative to transporting electricity. So this is a concept of the P2G power. Now electricity is converted into a hydrogen gas. Gas will be distributed and stored and then used by the in industry or home uses. Okay, so the speaking about offshore hydrogen pipeline, it can be cost effective and also reduce the infrastructure needs and of course, they contribute to decarbonizations and the energy storage. Energy storage means that the hydrogen gas, once inside the pipe, then this whole pipe system can be considered as a energy storage system. Since this pipeline, the volume-wise, is really huge, and the inside there is a pressurized, so the hydrogen gas can be stored and considered as the energy storage system. And offshore wind farm, electrolyzer can be installed. See, we learn about the electrolyzer can be installed on offshore wind platforms to produce hydrogen, which can then be transferred to onshore through a dedicated pipeline. This is the offshore pipeline. Let me show one video. Strom is one of the, there are several, many global company who does some business on this offshore pipeline system. And now one of them is the Strom. I'd like to very briefly show this video. So the title is Strom TCP. TCP means the thermoplastic composite pipe, hydrogen transportation.
As the global energy sector shifts its focus from fossil fuels to renewables, the production of hydrogen offshore will be an important part of our energy future. Hydrogen produced at offshore wind farms will be brought to shore with pipelines. At Strom, we design and manufacture thermoplastic composite pipe, TCP. It is the solution for renewable applications such as hydrogen. Thermoplastic composite pipe with high pressure capability and a smooth bore delivers the best solution for hydrogen. The flexible pipes have no embrittlement, no corrosion, and no fatigue. They are manufactured in long lengths, supplied on reels or carousels, and ready for offshore installation. The installation can be done with the same methods, equipment, and vessels used for today's wind farm electrical array cable installation. The first end, complete with end fitting, is pulled in through a J-tube. The flexibility and lightweight result in low pull-in tensions. The long TCPs ensure installation from wind turbine to wind turbine in one length without intermediate connections and are completed in the shortest time frame possible. The second end to the next wind turbine is pulled in through the J-tube using the quadrant method to manage the overlength in the pipe. Weight coating applied in the factory ensures the pipe remains stable on the seabed after the pipe lay. When needed by regulatory requirements, the TCP will then be trenched for further protection. At the seabed end of the J-tube, the exposed part will be stabilized and protected by the articulated pipe protection system. Once buried, the magnetic weight coating enables location of the pipe underneath the seabed by conventional detection methods. Strom's TCP is an enabler in the offshore wind to hydrogen industry, making it possible to reliably connect hydrogen-producing offshore installations at low cost and a long field life with no maintenance requirements. No maintenance.
I'd like to add a little bit of further information. Actually, this wind turbine blade, as you can see, that the hydrogen electricity will generate directly from this wind turbine blade. As you can see, this is called nacelle. This is a wind turbine blade. You know, it rotates with a lot of power thanks to a strong wind. And then in here, nacelle, we have a generator. So it's a huge generator. Each one will be about sometimes the 3 megawatts, or even these days 10 megawatts, the power generator. So once this is the conventional, wind turbine blade offshore. This is the offshore wind turbine blade. Now, conventionally, once we have electricity, we had long wires, and through wire, the electricity wired through wires to the onshore. But now, as we explained, I explained the concept of the P2G, power to gas. There is a direct electrolyzer here. So once we have generated electricity, and using the electricity, we generate hydrogen gas on the spot here. This is the electrolyzer. And now once we have a hydrogen gas, that gas now can be transported to onshore rather than electricity. So this is a concept of a P2G, and globally, this is a big trend. There are huge several advantages why it's better to convert electricity into hydrogen and then we transport the hydrogen gas through a pipeline. Anyhow, this storm produce a pipeline system to distribute this hydrogen gas. Again, once we generate hydrogen gas, this gas will be distributed through a pipe. So let's just go through one more time. This is storm.
As the global energy sector shifts its focus from fossil fuels to renewables.
Well, as you can see that as the global energy sector shift its focus from fossil fuels, the conventional oil and gas, now to
The production of hydrogen offshore.
Renewables such as the wind turbine blade and the solar panel and so on. Now, production of hydrogen offshore
will be an important part of our energy. Hydrogen produced at offshore wind farms will be brought to shore with pipelines.
Yeah, this is the key word. Hydrogen gas produced at offshore wind farm, this is offshore wind farm, will be brought to shore with a pipeline. As you can see that, again, wind turbine blade will generate the electricity, and then their electrolyzer will generate hydrogen gas. Now gas will be transported to onshore. So this video shows from between each wind turbine blade, there's a pipeline system.
At Strom, we design and manufacture thermoplastic composite pipe.
Now it's important to understand thermoplastic composite pipe. Why this pipe has to be a thermoplastic composite? Well, the composite means that there are fibers and resin system. And then if the resin is a thermoplastic, we call thermoplastic composite pipe. As I just mentioned, there is an embrittlement due to hydrogen gas in the metal pipe. So metal pipe is not recommended for this gas pipeline system. So plastic composites is much better and much more cost effective.
It is the solution to renewable applications such as hydrogen. Thermoplastic composite pipe with high pressure capability and a smooth bore delivers the best solution for hydrogen. The flexible pipes have no embrittlement, no corrosion, and no fatigue.
Well, again, because this whole line is made of the plastics composites, there is no corrosion issue and no embrittlement issue. And this is a very strong or durable in terms of fatigue. So there are lots of advantage over conventional steel pipeline.
They are manufactured in long, supplied on reels or carousels, and ready for offshore installation. The installation can be done with the same methods, equipment, and vessels used in today's wind farm electrical array cable installation. The first end, complete with end fitting, is pulled in through a J-tube. The flexibility and lightweight result in low pull-in tensions. The long TCP ensure installation from wind turbine to wind turbine in one length without intermediate connections and are completed in the shortest time frame possible.
So this video shows the connect between the wind turbine each wind turbine line the hydrogen gas. So as you can see that once they developed all the
installation can be done.
Developed this is the pipeline system which were produced, of course, in onshore
and ready for offshore installation.
So once developed, is directly to the on the to the ship, and then bring this pipe and then install in the
installation can be done with the same methods, equipment, and vessels. Today's wind farm electrical array. The first end fitting is pulled in through a J tube. The flexibility and lightweight result in low pull-in tension. The long TCP ensure installation from wind turbine to wind turbine in one length without intermediate connections and are completed in the shortest time frame possible. The second end to the next wind turbine is pulled in through the J tube using the quadrant method to manage the overlength in the pipe. Weight coating applied in the factory ensures the pipe remains stable on the seabed after the pipe lay. When needed by regulatory requirements, the TCP will then be trenched for further protection. At the seabed end of the J-tube, the exposed part will be stabilized and protected by the articulated pipe protection system. Once buried, the magnetic weight coating enables location of the pipe underneath the seabed by conventional detection methods. Brown's TCP is an enabler in the offshore wind to hydrogen industry, making it possible to reliably connect hydrogen-producing offshore installations at low cost and a long field life with no maintenance requirements.
At the bottom, you can see that this is the real pipe, the pipeline. Inner diameter, as you can see, there is not big. It is some between the 4 inches to say 6 inch. 4 inch means about the 10 centimeter to 20 centimeter or something. And then, very importantly, inside we have a plastic liner to prevent that imbrittleness. And then outside is covered with composite materials, carbon, and the sometimes glass or aramid fibers. And outside is also we call sheath, is a jacket to cover the pipe. So main point is this composites. Again, as I mentioned, this business and this industry is getting really bigger and bigger all globally. This is a new business and new technologies. Now, along with the moving to a hydrogen society, these types of new design, new material, and new application are a lot developed these days. So again, no hydrogen, no corrosions, and no imbrittleness. Long service life without maintenance is almost a maintenance free. Mainly because this is all plastic and no corrosions. The life is easily can be up to 30 years without any maintenance. Okay. Uh, if you type in the offshore pipeline hydrogen, and you can see, you can find a lot of informations. And it gives us all the overview of this offshore hydrogen pipeline. And also you can certainly find the onshore pipeline hydrogen. Uh, the Aramco. Aramco is one of the biggest company. They also work on these types of hydrogen pipeline system. Anyhow, you can see a lot of images. This is onshore. As you can see that all the pipeline transport for the purpose of transporting hydrogen gas. This is well, this represents this Norway to main Europe, and there are pipeline system, of course onshore and the offshore together. Again, there are a lot of informations, very informative, good informations, and you can take a look at and you can study. Well, this class, I like to introduce new technologies, which, you graduate student need to understand hydrogen related in industry. But the main point is that you have to study, go through topic by topic. So, okay, anyhow. So, once again, they are, well, they also said they're very cost effective. And okay, before that, I like to, we also need to understand how to produce these pipeline systems. This is the a way. There are many different ways. This is a one way of the producing this pipeline system. As you can see, this is a continuous, just keep continuous, starting from a liner and then covered with a carbon fiber, or sometimes many different systems, wires. But this doesn't show much. This will give you a good idea of how they manufacture the pipeline system. No sound. Okay. Let me explain. This yellow one is the representing inner liner. Previously it shows the color of a black, but this is a liner, plastic liner, which are already produced through extrusions, just a pipe, but it has to be a thermoplastic, thermoplastic. And then once we have this, we unwind and then fed into this continuous line system. So this pipe now here is the important point is this is where we wind a for example the carbon fibers, but sometimes the aramid fibers. So it's a fiber reinforcement stations. So as you can see that depending on the speed, feeding speed, and depending on the speed, we can have a certain angle, winding angle. Winding angle is one of the key in make withstand the high pressure. Now here, this guy is rotating in this counterclockwise, and this guy is rotating in clockwise, so that this can be, say, a plus winding, and this can be a minus winding. So there is another one. So basically, there can be, as you can see, that there are a lot of fibers. And number of these winding station is depending on the design. And there are looks there are a lot of stations, but anyhow, it didn't show clearly, but there are several stations where a lot of heat applied, so that this thermoplastic can melt and bonded well. This is a solid bonded pipeline. All the composites are also thermoplastic, and then inside the thermoplastic pipe. So now once we generate, this is the where we wind this pipeline system, final pipeline system. This is the brief idea of how to manufacture thermoplastic composite pipe. So in short, we call it TCP, okay, thermoplastic composite pipe. So this is a really good to know. Let's take a look at what is this. Oh, airborne. Actually, the airborne is the name of the storm. We just watched the video of the storm, and they changed their company name from airborne to storm. But anyhow, this video is by the airborne.
Hello, welcome to the Airborne Line for High Volume. In this movie, we'll explain the workings of the line and its components. Oh, Aperture. Slightly. Here's a closer look at the protocol.
Okay, well, so this is actually the airborne, and they are big tech business on the composite. So this is not for the pipeline system. but their business is the thermoplastic composite. So thermoplastic composite, they have a hot press and then similar to a stamping. They produce these types of production line. While speaking of the composites,
Hi guys. Body construction. There are millions of materials available.
I like to go through this procedure quickly. The reason is that the composite is the materials we are using for this pipeline, and also these composites are using for the hydrogen storage tank and storage will be covered the next class, but composite themselves are very important material, and the innovative technologies we need to understand. So let's just go briefly go through. Composites there are a lot of made of a lot of different fibers and resin system, and also there are a lot of different way of manufacturing.
What is your particular thing? Generally, nowadays it requires the material which is lighter than the bamboo.
Well, I will just go through quickly. So the aviation industry, where composite have been applied and a lot developed through this aviation industry, aerospace and airplane and so on. The material used in 787, the Boeing 787, there are almost all these structures are made of the composites. And also the automotive, especially requiring very high-end performance, they are using the composites. So composites are basically made of the fibers and resin. This is you can imagine this is a plastics. And then we can have many different angles which are designed and produced to carry the load very effectively. So there can be many different types of composites, fiber. And the particle reinforced means that rather than long fiber, we can have a particle structures. Very simple methodology is to use the wet hand layup. See, this is a mold, and we have composites, just the composite fabric, and then we have a resin system. And using just the roller, we just impregnate this resin into fibers, composites. So until this resin are fully impregnated into a composites. This is a real pictures. And then sometimes we can spray, especially the short fiber, we can spray. And sometimes we can compression molding. This is the composite compound. Then we just have a mold, low and upper, we just compress. This is the another method. Filament winding is the very common methodology, even apply for the pipeline system.
So the filament winding possibilities are three.
So basically, let's say we have a pipe or we have a storage tank. This is a fiber supplying, fiber toes, and then I go through a resin bath. This is called resin bath, where resin will impregnate into fibers, and then we wind. So in this stage, fibers and resins are wet. It's not solid. So we can have a very different types of I mean, is a liquid. So we can have a even small diameter or large diameter. This is very typical way of a filament winding. Well, there can be a pultrusions. Pultrusion means that we have a very special dye, and inside there is a dye, and then fibers and resin system and go into this dye with a lot of heating, and then this structure is, since it's a plastic, is immediately cured or solid, become solid. So here fibers and resin, mostly liquid type, but once through these heaters, then products will be solid. So this pultrusion is called pultrusion, not the extrusion. It's similar to extrusion, but it's a pultrusion. Why? Pultrusion means pull. It comes from pull, because this here is the kind of a station where we are pulling this product. This is a very common method for mass productions of the composites. Well, I just picked the one, video, briefly covered the composites, but you can find a lot of good video and the informations. So the again, the understanding composites can be very important for the hydrogen distribution system. Hydrogen, the storage tank, mainly because the plastics is the one have to be used because the steel cannot be used because of its imbrittleness. Okay, well, let's take a 10-minute break. This is 3:55. Let's start about the 4:10. Well, again, the key point is that how to safely distribute hydrogen gas from production site to uses site. So one of them, among them, this hydrogen pipeline system is the most cost effective, and the we can design and produce. Okay, this is the graphical overview again. Hydrogen integration with offshore wind farm. There can be several different models. The one we just watched it was the like this at the bottom. The Strom video shows that each wind turbine blade has its own electrolyzer, and so the hydrogen gas will generate from each wind turbine blade. And again, each wind turbine blade has its own electrolyzer. So the strom shows this pipeline system, and then H2 will transfer to onshore. Then we can store into another tank or distribute in the onshore. And another method is that rather than individual electrolyzer, we just collect all the electricity from each wind turbine blade, and then we have one big electrolyzer, and it's a centralized electrolyzer, and then transfer it to the onshore. This is the one different from this third choice. And the first one is the offshore wind farm with the onshore electrolyzer. What does it mean? Each power will generate electricity, and then electric power is through wires, electric wire, and then electrolyzer is onshore, not the offshore. Electrolyzer can be onshore, and then we generate H2. While so this is representing this is the offshore, and this side is the onshore. So electrolyzer is the onshore, and but this is all connected through electric wires, and then electricity. Again, this one is the own electrolyzer. So we need a pipeline from individual wind turbine blade, and this is the one. So this pipe system we call onshore pipeline, and yeah, I mean it's not that complicated concept, but we understand there can be several different ways of hydrogen pipeline models. And also, so onshore electrolyzer, offshore electrolyzer, and the offshore electrolyzer on-site is a own turbine. This the one, and this is the centralized offshore. Each one has the pros and cons, and in terms of flexibility and cost effectiveness, and the scalability. Scalability means that we can extend it to more power and more site, and so on. Now, we Korea plan to have lots of offshore wind farms and offshore wind farm location in Korea. And as you can see in the southern part of our country, we plan to have a offshore wind turbine blade, and also along the Jeju Island, there is a lots of plants you can take a look at, and especially we have to consider how much wind we can have. So we have to first analyze how much wind we can have, which basically will be turned into electricity. So a lot of study needs to be done to understand where can be the best spot. This is let's take a look at KF Wind Consortium to build a floating wind farm in South Korea. Well, let's see. Yes, there are a lot of plans for wind turbine blade offshore. Especially in this one is the Ulsan, coast of Ulsan metropolitan city in South Korea. Develop a 5 megawatt. If we have one wind turbine blade is a 5 megawatt, we will have a 500, means that we need a 100 of the wind turbine. It is called Korea floating. For the wind turbine blade offshore, there can be several different methods. This one is a floating type, floating wind power, Korea floating wind power, KF wind. Yes, there can be many different plans, and strongly supported by the policies, and all we work together to moving toward the hydrogen society. So it is really important to understand what kind of wind turbine blade and also offshore, and then there will be a huge offshore pipeline, which is not yet planned yet. But there will be a huge plan to have an offshore hydrogen pipeline system. So as you can see, it's a Jeju Island, Korea offshore wind turbine. Yes, well, there you can easily find. One point, the most important point I like to emphasize is that, the offshore wind turbine blade is the most effective way of a green hydrogen and through an electrolyzer. Now, once we have a hydrogen gas, how can we distribute? Well, through pipeline systems. So you can imagine how much job will be created. As you can see here, this is a Hyundai. This is too long time ago. But anyhow, there were huge plan more than 10 years ago. And then nowadays, this boom is back to again. So now I like to give you an overview of the background of a thermoplastic pipe. Reinforced means that composite. Aramid, reinforced thermoplastics, and glass. So there are several different applications in Netherlands, and the product is a Solopost. Solopost is the company. They produce the onshore pipeline. Let me go to. This is the onshore pipeline system. As you can see, yes, this is much easier than offshore because this just implement into underground, not that deep, just 2 meter deep or so. And the junction is also very important. To pipe, we have to have a junction, connectors, and so we need to develop that one. So this is the Solopost pipe, flexible pipeline. Why they call it flexible? Well, as you can see that this, for the transportations of this pipeline system, this has to be flexible, so that this has to be packed in a. So this pipeline system have to be very flexible. If it is not flexible, then this pipe can be very straightforward, straight. Then it's very difficult to handle. Actually, this flexible is much preferred, as we briefly discussed. And the how to make the flexible, there can be a lot of different ways, like can be very different layers. Well, this is not just for the hydrogen pipe, but this is a general flexible pipe, which are widely used for oil and gas. But the is also good to understand the flexible pipe. And then a flexible pipe can be used to transport the hydrogen gas. To do so inside, and all has to be composite. So anyhow, as you can see, there are lots of different types of flexible pipe. Even deep water, deep means that as deep as a 3,000 meter deep. And so again, this is not just for the hydrogen, but general purpose is for the oil and gas applications. So this industry is big, and even in Korea, we are trying to develop this offshore and onshore pipeline. Anyhow, there are technology and company by country to country. This is the Netherlands. This is the Solopros pipeline. While the fiber reinforcing can be aramid or steel or and also this is the by the way the thermoplastic pipe for mainly for the onshore. That's why they are using steel wires as well. Steel is not just a solid steel. This is a steel wires and glass, and a lot of different countries have their own companies and with the different technologies. Speaking of Netherlands, there's I just like to introduce the current status and how big this hydrogen industry is booming. And there is a hydrogen 2025 and this May, Netherlands. And as you can see, huge conference and the exhibitions for the hydrogen and this hydrogen so this May, this is one big exhibition, leading hydrogen solution at the World Hydrogen Summit exhibition in the Netherlands. The reason I'm showing this one is the how big this new industry is forming now, introducing huge trend. While this slide actually prepared to present to outside. Actually, the 3P.com is the one startup company which were formed, strongly supported by the Hanyang University in our lab, composites lab. So we are producing the flexible riser and the thermoplastic and many different onshore to offshore. We mainly design and work with industry to produce this one. One of the company is the Ben9. Ben9 is the Chinese company. They are working on the onshore offshore thermoplastic pipeline, and even for the hydrogen. Actually, the Ben9 is the company who produced the machinery lines to produce the pipe. So this is the one for the bonded. Bonded means that the old solid pipe using pipe glass fiber. Well, this is the oil and gas industry.
Based on the demand, advancing its energy infrastructure, market size of thermoplastic pipe expected to reach approximately $3.6 billion. CFPCP RTP is 3 times the bigger PBO, the middle being bonded fiberglass and the outermost. And the most important fiberglass glass pipe at the middle hand.
This is the mainly for the onshore. Onshore, we are using the glass fiber, not the carbon fiber.
Makes it an ideal solution. As a result, fiberglass not only also fiberglass plates usually assembled middle layer fiberglass plates. Nowadays, there are
Okay, this is the very similar to the machine which was shown by the Strom. Concept is the same. This inner liner is moving continuously in axial direction, and there is a machines wrap the glass fiber. It's a glass tape actually. Glass fiber and the all PE. So this will be a wrap.
First one is the planetary wrapping. The second one is the coaxial wrapping. Van chooses to do. Planetary wrapping is multiple wrapping. Potential limitation of fiberglass tape. So smaller widths of fiberglass tape usually use 50 millimeters. In addition, planetary wrapping machine inevitably has problems with the gap. It can also cause trouble in production process. And then too large. The coaxial wrapping machine is perfectly flat.
Firstly, the fiberglass tape can be adjusted in width up to 350 millimeters, which can save more time and cost of wrapping.
Well, this video, they are trying to emphasize their new technology, this wrapping machine. Their wrapping machine is can wrap a very wide glass fiber tape, even up to 300 meter. And this is the conventional is only 100 meter. So this can reduce the gap between the tape. Well, this is very detailed technology, but as you can see that how this technology can be innovated, there are a lot of room to study and develop.
Even if there is a gap, it is very convenient to angle production and time. In addition, the coaxial cylinder does not require down fiberglass tape, which greatly saves the cost and time of downtime. After the fiberglass tape is wrapped, the heating process of the CCP is also very important. The pipe may be deformed if the temperature is too high or too low. The unique and patented technology of fast cooling and fast heating solves this problem and achieves the best quality of fiberglass tape wrapping performance.
But the leading and unique technological advantages of vanline also have certain competitiveness and industry leadership in the market. Vanline has a long-term and stable cooperation with the premium customer, China Lesser, which is the largest pipe manufacturer in China. Vanline and China Lesser Group are working together to develop advanced TCP and also achieved a breakthrough in hydrogen energy transportation. It is known for its comprehensive coverage of important national and international events. The test signifies a major milestone in hydrogen energy transportation, demonstrating China's commitment to advancing its energy infrastructure and embracing cleaner energy sources. Advancing its energy
Well, here shortly they emphasized their vision, especially in China. They are making a lot of effort to move toward the hydrogen society. So using the green hydrogen gas and then to distribute this pipeline system.
Cleaner energy sources.
Okay, so this is a very short introduction of a band line, which is located in the Shanghai, in China. And as you can see that there are lots of different business and technologies and so on. Actually, this slide was prepared to present to band line from 3P.com. This is the our company. And then this slide, we already have a lot of technology, and we introduced this technology to a band line. And the commercially available hydrogen pipeline, as just mentioned, this is the one produced by the Soloforts, coils of up to 400 meter, which is really good. And the inside there is a pressure. Of course, this pressure is up to higher the better. But the if higher, then pressure the pipe cannot be bent like that. It should be bent. This is a very important characteristics of a pipeline. So have to be support this bending moment, and at the same time we have to this pipe have to support all the internal pressure. Well, internal pressure, how much the pressure? Well, here it says 42 bar, which is not high, but these days usually 70 bar. 70 bar is the one. So 70 bar, as you can see here, 70 bar. Okay. Here it's 150, 70 is about here. Okay, so density will be about 10 gram per liter. So not as high as the hydrogen tank, but considering the volume of this pipeline, the internal volume, as you can see how much the hydrogen gas can be stored in the pipeline. See, it's important to understand the pipeline can be considered as a hydrogen storage system. Okay, pipeline is not just for the distribution, but it can be a storage system because the internal volume is so big, and the with the density about the I would say 10 gram, or well, about the 5 gram is also okay. We can easily let's quickly calculate how much the hydrogen gas can be stored in a pipeline system with a certain pressure. Okay, so the I would say 70 bar. Bar is about the pressure, and this gives us how much the density. Let's say again, 70 bar is almost half. So about here, I would say 6 gram gram per cubic. Oh, sorry, this should be no centimeter. What's the unit? It's a liter. Yeah, that's right, liter. Okay, so pipeline, how much the hydrogen gas can be stored in a pipeline. Okay, so the this is the internal pressure, and this is the density. Now let's consider the length of this pipe. I will say 1,000 meter, and the diameter of the pipeline system. The diameter usually say 5 inch. 5 inch. 5 inch is the 105. So 0.125 meter. Okay, very simple. We have a pipeline with a inner diameter 0.125 millimeter, 125, which is the about 5 inches, and then length will be a 1,000 meter. Density is like this, and then how much the mass of hydrogen. Now, to do so, we first need to calculate what? The volume. What will be the volume? Okay, first let's give a name. Changing, create the form selections. The left column. Okay, so this cell has a name internal pressure, and this cell has the name of density, length, and diameter, and volume. Now the volume is simply the diameter square divided by 4, multiply the pi, right, times the length. This is simply the volume in terms of cubic meter, and we need to change this volume in a liter. How to change the volume to the liter? Cubic meter to okay. Oh yeah, simply 1,000 liter. So this is the 1,000 times the this volume. Okay, so this is the liter. And now the mass of hydrogen will be simply the volume. Oops, we don't have a name. Okay, this one equal this the volume in liter. Now multiply by the density. Density is the gram per liter. So this is the gram. Okay. Now it can be converted into a kilogram. So simply divide by the 1,000, and this is the kilogram. Now, as you can see, that the point is that about this much diameter and this much length, 1 kilometer, and then we can have 73 kilogram of hydrogen. So I just want to give you an idea, the mass hydrogen for nectar. How much the hydrogen gas are needed for the one fuel cell vehicle by Hyundai Nexo? This about the 6 kilo, okay, about the 6 kilogram of 6 kilogram of hydrogen is needed for the full tank. So actually, as you can see that about the 10 car can be fed. We can cover about the 10 hydrogen car using this much the hydrogen pipeline system. Of course, if we increase the pressure, like for example, 700 bar at the room temperature, density will be 40. So if we increase the 40, like the 700, and then density will be 40. Now, as you can see, 490 kilo, as you can see how much the hydrogen gas. Well, this is just a simple equations and formula, and get the idea about the hydrogen, the distribution pipe system can be used as an energy storage system. That's the one I like to emphasize. Hello? Well, we don't have to use the ChatGPT, but just the gives you idea, a better idea, and how quickly we can get a let me just ask, how can we use the pipeline? Now, as you can see that using pipeline as a hydrogen storage system is a practical and very cost-effective method of a large-scale, long-duration hydrogen storage, especially when integrated into hydrogen production distribution infrastructures. The concept, pipeline as a hydrogen storage, point I like to emphasize is that the pipeline is not just for the distribution. It can be used as a hydrogen storage in certain cases. So balancing supply and demand and decentralized storage and so on. There are a lot of, typically 30 to 100 bar for distribution line can go higher, of course, can increase higher for storage oriented system. And the material can be, this is the carbon steel, stainless steel, or composite pipe. Modern system prefer composite line pipe to reduce the embrittlement. This is the one topic we already covered. And the pipe diameter can be about the 5 inches, can store more hydrogen. Pipe must resist the hydrogen embrit and so on and so on. Well, sensors and the control system can be used. It happened to have here. Storage capacity estimate. Pipe length, the diameter, and then operating pressure, and so on. And 10 kilo, and then 60 to 70 tons of the hydrogen. And there are challenges. Okay, well, they said 10 kilo and the 12 inch and 100 bar. Let's double check their calculations. Well, I didn't expect that they would give us the formula and the way of the storages, but simply we asked whether the pipeline system can be used as a storage or not. This ChatGPT give us some example of the hydrogen. So let's double check. 10 kilo, 10 kilo. Okay, where is the length? Here is a 10 kilo. And then diameter is a 12 inch. It's 300. Diameter is rather than this, we have a 300. And then 100 bar. Now 100 bar, we need a density. 100 bar is about here. So density will be about 10. Okay, just approximations. So density will be 10. Now the give us 7 ton. And how come they give us 70 tons? Density is correct, length is correct, the diameter, and then our volume. This is not important one. Well, 12 inch. 101. Okay. Let me double check the what is the density of hydrogen gas. at room temperature and under 100. Okay, density they said 7.8 kilo or cubic meter. 7.8 hours is like the so density density is 7.8 kilo. Okay, yeah, that is about the right, 1,000 and 1,788. That is correct. The length, it had to be a 7 ton, not a 70. Huh. Now they change it to a 5 ton. Now this is correct. Well, they said first 70 tons. Well, so don't just trust the ChatGPT. You need a double check. Now it gives us the correct number, like the 5 ton. 5 ton is the about the our calculation. Our calculation is 7 ton. Anyhow, where did the 60 tons come from? My gosh, they mentioned it now. So anyhow, they were wrong, and then they don't even know where this 6 tons comes from. Anyhow, okay, let me. Where is the locations? Where- April 2025, the longest operating hydrogen pipelines, the Air Product Gulf Coast hydrogen pipeline network in the United States. This extensive, okay, plan to extend 170 kilometers with a diameter of the 800 millimeter. So huge. Design pressure is 7 megapascal, means 70 bar. Okay. So anyhow, you can learn a lot from these new informations. And again, I like to really emphasize the how can we prepare for this new industry, new business. So we should be able to better understand this pipeline system, not only for the distribution, but also a storage tank as well. Okay, so this is the one, and then design of 6 inches, 6 inches about 150 onshore hydrogen pipeline. This is our design. Basically, we have an inner liner, outer liner, and then inside there's a composites, mainly glass. And this can be curved like this. And then we have two critical load. One is bending, and the other one is the pressure. And depending on so we can actually optimize the winding angle. We saw a video how these fibers are wrapped around the pipe, and then we can design these angles. So sometimes hoop layers, sometimes helical layers, and so on. And also, I like to emphasize that the connector is also important. There are Sulfur's connector. This is our connector made of a full plastics. Connector, we have to make the completely leak-free. So this is the systems. We have we can have all plastics except this connecting bolt. So it's important. Well, this is the same winding structures as before. We saw this how to manufacture this pipeline system, and then Magma is the one company which produced this composite pipe manufacturing. Well, since we are using the ChatGPT, we can continue to use that. The Magma is the one company which produced the composite TCP using the carbons. Magma is founded in 2010. Their production name is M-pipe, made of the PEEK. You know, there can be a lot of different thermoplastic, but they produce the pipe using the PEEK, polyethyl ketone. And this is one of the strongest, most durable thermoplastic. And so Technip FMC is merged, invest Magma, and now they are considered as one company. And actually, our lab, composite lab, are working with Technip for more than 10 years, and to develop this pipe. So the GLDMB is the important code certification, ST F119 is the code we have to meet to develop the so the F119 again is the guideline. This is a guideline to design the thermoplastic composite pipe. I like to emphasize how important to understand the certification and standard. And in general, no matter where you work, no matter what kind of job you have, you need to understand this kind of certification, the procedures, designs. And as you can see, the design pressure and temperature have to be specified. Intrastructural integrity means that axial strength and internal pressure, external pressure have to be specified. And liner and barrier design, where PA12 and PEEK, fiber matrix interface performance, in the composite of fiber and matrix and interfacial. We call it sizing to be very important for well bonded, and manufacturing and quality control must comply with the qualified manufacturing procedures. For your information, to get the certain certification of a product, the product itself has to be well developed, but also manufacturing and quality control have to be also well established, and qualification, testing, and so on, installation and operating, and document and traceability. So ST F119 is a very important certification guideline. Okay. So as you can see, Magma and Technip FMC, they are working together to develop the all carbon fiber PEEK pipeline system. Okay, this is a short video showing the Magma, how they produce the
put pressure on deep water. Our response to the challenge is to use technology to deliver cost-effective development of deep water reserves. M-pipe is a game changer. Our aim is to reduce cost, reduce time to first oil, and significantly simplify engineering. We combine carbon fiber with the most advanced oil field pulp, fusing them together using robots and lasers. The result is the world's toughest carbon fiber. It's lightweight. It doesn't corrode or degrade in oil field. It's flexible and acceptable to high pressure and high temperature performance. Amplified's low permeation makes it ideal for all types of fluids.
Okay, so that is the short video introducing how the magma produced the composite pipe TCP. This is the robot system in our lab, our composite lab. This is the very short length, but the similar methodology to make the pipe. This is a glass and the PE composite. Another very interesting topic in this regarding this pipe is the health monitoring system. Means that there can be a sensor attached to a structures, for example, a pipe, and then whenever certain excessive load is applied or some cracks is generated inside the pipe, we can have sensors to detect such the damages. See, as you can see that this pipeline system is so important. Not to they should not break, they should not get damaged. So it's better to have an online monitoring system. It's called the health monitoring, and then we can collect a lot of signals. And then we can have we can predict the life or predict the damage or something. So anyhow, well, there is a topic to bioplastic, but that's not the main point. Actually, this is the offshore pipe. Is again the similar topics as I mentioned. This is the kind of a design program we developed the HyFlex program. This is a world #1 tools to design this TCP, covering all kinds of the inner pressure, bending, and creep and fatigue. And so as you can see, imagine this pipeline can be also used as a riser for oil and gas. In the seabed, there can be a lot of oil and gas. And using this pipe, we can extract the oil and gas. This can be as deep as 3,000 meter deep. So depending on the location, this pipeline system can be subject to a different load. Here is a lot of external pressure. Here, a lot of axial load. So the loading condition can vary from position to positions. Okay, so that's the one I like to cover. And then this slide, actually, you can, this is categorized as a pipeline system. And you have a link, the link, you already have a link. But once again, I'm gonna share this link again for you to easily access this. Okay, so I'm gonna copy this link again. You can easily access it. Okay. Well. So we go a little bit dive into the understanding the pipeline system, which are mainly main component for distribution of the hydrogen. And I hope you understand this industry. Again, I like to emphasize how big this industry can be. And if you are interested in designing of structures, designing of new materials such as the composites, and this is the one you can work on that. Okay, well, this is the subject I like to cover today, and the class will be dismissed. If again you have any questions, and please, feel free to ask through Katalog. Okay. Thank you so much. Bye. I will upload this video for sure. Thank you.